Today we will learn common base amplifier, its equivalent is small signal circuit. Uh, we have already learned hybrid pi model. We have already learned hybrid pi model. We have to evaluate the common base amplifier in small signal terms. What is a small signal? That is the AC analysis. First, it is your circuit which is in common base. This is the capacitor. Why do we use capacitor here? That is blocking capacitor. Why do we use blocking capacitor? To block DC signal. That is your biasing voltage to mix with your AC signal. That capacitor block that DC to mix with AC. Here there is a base resistance, one more capacitor that is known as bypass capacitor. Why do we use bypass capacitor over here? Here bypass capacitor is used to bypass the AC. It provides the shortest path to AC and block DC. And one more capacitor that is C2, it is also known as a blocking capacitor. This is R3, that is your VCC, that is your VEE. This is your transistor. We have to convert this common base transistor to its equivalent in small signal analysis. What is the step for that? First step, remove your voltage source. Second, what is the second step? Short circuit. Capacitor. And third step. What is third step? We have to draw equivalent hybrid by model for transistors. Okay. So we need to follow three steps. First, we remove the voltage source. Second, we short circuit all the capacitor, and for third, we draw the equivalent transistor transistor equivalent circuit. Okay. Now we draw the circuit. Voltage across this resistance is voltage across this resistance R pi is called V pi, and this is the dependent current source GM V pi, which is dependent upon the V pi, and this is the RE resistance, which is connected between the ammeter, and base. This is your ammeter, this is your collector, and this is your base terminal. Okay, this resistance is RC, and this resistance is RL, and output across this resistance is equal to V naught, and current flowing through here, it's equal to I of naught. This is your voltage supply, and this is the RS, that is the source resistance. In this equivalent circuit, we need to calculate four parameters, that is AI, current source, AV, voltage source, RI, and that is input resistance, and R naught, that is your output resistance. First of all, we'll be calculate the voltage gain. Voltage gain. What should be the voltage gain? Output voltage upon the input voltage. And what is the output voltage? V naught. And what is the input voltage? Vs. Okay. So that is your voltage gain. First, we need to calculate the V naught and Vs. So through the diagram, you can see that V naught is equal to minus Gm V pi multiply with RC parallel with RL. Okay. From here, you can get this current is flowing through combination of this RC and RL. That is why the voltage across these two resistance are your output voltage. Now apply KCL at ammeter node. So if we apply KCL at ammeter node, what would we get? Vs minus Vs minus of V pi plus V pi upon R pi plus V pi upon Re plus Gm V pi is equal to 0. How do we get this equation? Actually, we are applying KCL at this node. One current is coming through here, one current is coming through here, one current is coming through here. Okay. At here, what is the voltage? V pi only, minus of V pi. So through which we can calculate this equation. Now rearrange this equation, taking V pi common. What should be the output? 1 by Rs, 1 by R pi, 1 by Re plus Gm is equal to minus of Vs upon Rs. Now we know Vita is equal to Gm R pi. Okay, Vita is equal to Gm R pi. So we can replace that Gm by this, and we could have that equation V pi is equal to 1 by Rs plus 1 by Re plus 1 plus theta upon R pi is equal to minus Vs by Rs. Okay, how could we get this one? Any idea? Okay, look at here. You know, here in the last equation, can we write like this? 1 plus Gm V pi upon Gm, sorry, 1 plus Gm R pi upon R pi. Okay, and Gm R pi is equal to your beta only. So it would be 1 plus beta upon R pi, or better, can I write like this? So this term comes from there only. Okay. So what would be the V pi equal V pi value? V pi is equal to minus Vs by Rs where Rs, Re and R pi by 1 plus beta is in parallel combination. We have to put this value at V naught equation. What was the V naught equation? V naught was minus Gm V phi Rc parallel with RL only put here. So what should be the V pi value? V naught Gm again minus minus plus Vs upon Rs with Rc parallel with RL and Rs parallel with Re parallel with R pi 1 plus beta. Okay, this will come if you take, if you send the V pi there, V naught by Vs, that will be equal to this only, Gm by Rs Rc parallel with RL Rs Re parallel with R pi by 1 plus beta. That would be your voltage gain, AV. Now assume, because Rs is very less, so we are assuming Rs is tending towards 0. So AV would be Gm Rc parallel with RL only. That would be your voltage gain. Now we have to find second term, that is current gain, that is AI. What should be the AI? Output current upon the input current. And what is the output current? Output current is I naught. And what is the input current? I. Okay. So first of all, we will calculate. We have to. We will apply KCL at emitter node. Apply KVL at emitter node. KCL at emitter node. That would be II plus V pi upon R pi plus V pi upon Re plus Gm plus V pi is equal to 0. Okay. How? We are applying KCL at node this one. This is your current II and this is your current I now. One current is coming through there. This current is coming here. And this current is also coming here. Okay, got this point? So this would be the equation for this. Now what should be the II equal to G pi 1 by RE plus 1 by R pi plus GM equal to minus of II. Okay. The same way we have calculated earlier. Again we apply V pi common 1 by RE plus 1 plus beta R pi equal to minus of II. Okay. So V pi is equal to minus of II with RE parallel with R pi 1 plus beta. Now we need to calculate I naught. Okay. So how do we calculate the I naught? Look at here. This is current flowing through this direction. If we want to calculate current flowing through RL only, we need to apply current divider rule over here. So apply current divider rule. So what should be the I naught? I naught should be minus GM V pi. That is your current flowing, and that would be RC upon RC plus RL. Now substitute V pi at in this equation. So what should be the value? Minus GM II with parallel RE and R pi upon 1 plus beta, and this value RC upon RC plus RN. Okay, that would be your value. So what would be the I naught upon II? That is your current gain. I naught upon II would be GM RC upon RC plus RL with parallel combination of RE and R pi 1 plus beta. Okay. Now if we consider RE tending towards infinity and RL tending towards 0, in that case AI would be GM R pi upon 1 plus beta. And what is GM R pi? It's equal to beta only. That would be GM beta plus 1 plus beta. And this value is alpha only. This is your current gain equation. Now we have to calculate input resistance. It is Ri. What should be the input resistance? That would be the input voltage upon the input current, isn't it? Here, what we do, for determining the resistance, we have reversed the polarity of the current control voltage. Okay, that is control voltage means V pi, which reverses the direction of the dependent current source. After that, we apply the KCL at node E. After reversing the polarity of V pi, okay, for sake of calculation, we just reverse the polarity of that, through which the polarity of dependent current source will also be changed. Now, what would be the resulting equation? That is II is equal to IB plus GM V pi. That would be equation. You're taking Ri at this point. This is your input resistance, whereas overall input resistance will calculate it from here only. Okay, we will call it as Ri dash. Now, what is IB? V pi upon R pi GM V pi. Okay, or if we take common V pi, that would be 1 plus GM R pi upon R pi. Okay, And what about this? This is equal to V pi 1 plus beta upon R pi, isn't it? Now tell me what is the Ri dash? Ri dash is equal to their voltage, okay, that voltage upon this current II. So Ri dash is equal to V pi upon II would be equal to R pi upon 1 plus beta, okay, that would be your output resistance. Now we have to calculate output resistance. It is R naught. How do we calculate R naught? First, we short the all voltage source, independent voltage source. Okay. Second, let us assume Rs is equal to 0. If we short dependent source Vs is equal to 0. Okay. If we short this one and Rs is also 0, then it will act as a short circuit over here. Then Re would be 0, R pi would be 0, and voltage across R pi is 0. Then this is act as an open circuit. Okay. So what should be the output? What should be the output output resistance? Output resistance R naught is equal to RC. Okay, that is your output resistance.